Hi everyone. In this session, I would like to explain about the concept in time dependent probability. In that, I would like to explain a new concept, that is network reliability. Okay. In this, we have different networks already we have discussed in previous concepts, that is using binomial distribution. Here, this is using time dependent probability. So in that, first one is series system, second one is parallel system, third one combination, series parallel, system, and fourth one is non-series parallel system. Now we'll see one by one. Here the main concept is, here I would like to explain this network reliability analysis using time dependent probability. First one is series system. We'll see. Okay, for that, here I'm taking one system, they are connected in series. Okay. Now each component having its probability of success and probability of failure, as we have discussed in binomial distribution. Here also, just now you consider that is let R1 of t and R2 of t. These are the probability of success, probability of or probabilities of success of components 1 and 2. Okay, we know that already discussed. This is reliability function R of t, that is R1 of t. This R1 of t is equal to e power minus lambda 1 t, where this R2 of t is equal to e power minus lambda 2t. We know that where these two, lambda 1 and lambda 2, lambda 1 and lambda 2 are the hazard rate functions. Sorry, hazard rate constants. Now if you want to represent, like consider let q1 of t comma q2 of t are the probability of failure for what? For component 1 and 2. So now what will be the q1 of t? That is equal to 1 minus r1 of t. That is equal to 1 minus e power minus lambda 1t. Clear? Now q2 of t is equal to 1 minus r2 of t, that is equal to 1 minus e power minus lambda 2t. Okay. Now as this is the series system, you know that how the total system reliability will be. As this is the series system, now total system reliability Rs of t is equal to product of their reliabilities, that is R1 of t into R2 of t, that is equal to e power minus lambda 1t into e power minus lambda 2t, that is equal to e power minus of lambda 1 plus lambda 2 into t. Okay. Now this is the Rs of t. Here where this lambda 1 plus lambda 2 I am considering, let lambda 1 plus lambda 2 is lambda e, that is equivalent failure rate. Equivalent failure rate. So now I am writing the above equation as, that is our total system reliability Rs of t, where S stands for system. Rs of t is equal to e power minus lambda e t, where lambda e is the equivalent failure rate. Now if you see the main important reliability measure, that is mean time to failure, mean time to failure, that is MTTF is equal to, we know that is integral 0 to infinity Rs of t into dt. Okay. So now already we know that Rs of t, what is that Rs of t? So from that here I am writing as this is integral 0 to infinity Rs of t Rs of t is equal to e power minus lambda et into dt. Now if you simplify this, if you are integrating this e power minus lambda et, what will be then? E power minus lambda et by minus lambda e, that is the inputs, that is the limits 0 to infinity, that is equal to 0 minus of minus 1 by lambda e, that is equal to 1 by lambda e. So now what is this mean time to failure reliability measure? That is MTTF of a series system using time dependent probability evaluation is 1 by lambda e, where lambda e is the equivalent failure rate, that is equal to 1 by lambda 1 plus lambda 2. So now this is the mean time to failure when two components are connected in series. Two components are connected in series. Okay. Similarly, if you consider three components in series, for suppose three components in series, for suppose, like one more component I am taking extra, that is component 3, 1, 2, 3. So now Rs of t is equal to R1 of t into R2 of t into R3 of t. Okay. That is equal to what it is? E power minus lambda 1t into e power minus lambda 2t into e power minus lambda 3t. That is equal to e power minus of lambda 1 plus lambda 2 plus lambda 3 into t, where this lambda 1 plus lambda 1 plus lambda 2 plus lambda 3 is the equivalent failure rate, that is lambda e. Okay, so now finally Rs of t is equal to e power minus lambda et. Now for this three components in series, if you write the mean time to failure, that is equal to integral 0 to infinity Rs of t, that is equal to integral 0 to infinity. Okay, what is that? E power minus lambda et, that is equal to e power minus lambda et by minus lambda e 0 to infinity. So finally what you will get for this 0 minus of minus 1 by lambda e, that is equal to 1 by lambda e, that is equal to 1 by lambda 1 plus lambda 2 plus lambda 3. Okay, so from this you can observe that is if n number of components are connected in series, what will be the reliability measure, that is mean time to failure. Then we will see now mean time to failure for n number of components are connected in series will be the general formula I am writing here, that is sigma I is equal to 1 to n, sigma I is equal to 1 to n lambda I. Yes or no? Yes or no? So here in this formula, suppose if 4 are 3, then plus 4 also there. If 5 are there, 5 components are series and left up to n components, you can write this formula. Okay. Now this is the general formula. Then this is equal to 1 by lambda e, where lambda e is this one, sum of all individual components failure rates. Okay. This is regarding series system network reliability evaluation. Second one is parallel system. Same two components, just now I am connecting in parallel instead series. I am connecting them in parallel. See what will happen. So these are the components 1 and 2. Similarly, I am considering R1 of t, R2 of t for components 1 and 2 probability of success. Similarly, Q1 of t, Q2 of t for the same components 1 and 2. These are the probabilities of failures. So you know that as these two are in parallel, it's better to go for first Qs of t, just product rule. Yes or no? Now Q1 of t into Q2 of t. Already we discussed, right? So now Q1 of t is equal to what? That is 1 minus R1 of t into 1 minus R2 of t. Okay. That is equal to C 1 minus R2 of t minus R1 of t plus R1 of t into R2 of t. Now finally what we need to calculate the Rs of t, not Qs of t. Rs of t, that is equal to 1 minus Qs of t. That is equal to 1 minus of this, 1 minus minus 1 plus R2 of t plus R1 of t minus R1 of t R2 of t. Finally we get R1 of t plus R2 of t minus R1 of t R2 of t. This is simple union rule of reliability. That is for system reliability. Okay, now I am substituting what is that. This now Rs of t is equal to e power minus lambda 1 t plus e power minus lambda 2 t minus e power minus lambda 1 t into e power minus lambda 2 t. Okay, now reliability measure is C. Mean time to failure. It is equal to integral 0 to infinity Rs of t dt. That is equal to integral 0 to infinity e power minus lambda 1 t plus e power minus lambda 2 t minus e power minus lambda 1 t into e power minus lambda 2 t into dt. So now that is equal to, if you integrate, then e power minus lambda 1 t by minus lambda 1 limits 0 to infinity plus e power minus lambda 2 t by minus lambda 2, this is 0 to infinity, minus e power minus lambda minus of lambda 1 plus lambda 2 into t by minus lambda 1 plus lambda 2 0 to infinity. Now that is equal to 0 minus of minus 1 by lambda 1 plus 0 minus of minus 1 by lambda 2 minus of 0 minus of minus 1 by lambda 1 plus lambda 2. Finally, our mean time to failure will be 1 by lambda 1 plus 1 by lambda 2 minus 1 by lambda 1 plus lambda 2. Now this is the equivalent failure rate. Now where 1 by lambda E is equal to 1 by lambda 1 plus 1 by lambda 2 by 1 by lambda 1 plus lambda 2. Similarly, for n number of components, we can write like this. Same if you consider n number of components are connected in series, or 3 components are connected in series. For 3 components, for suppose 3 components. 3 components are connected in series. Then what will be the 1 by lambda E now? 1 by lambda 1 plus 1 by lambda 2 plus 1 by lambda 3 minus 1 by lambda 1 plus lambda 2 minus 1 by lambda 2 plus lambda 3 minus 1 by lambda 1 plus lambda 3 plus 1 by lambda 1 plus lambda 2 plus lambda 3. Okay. This is regarding parallel system. Okay, similarly, you can do it for the series parallel and non-series parallel. So, but that non-series parallel system is not there in the syllabus actually. That's not required to discuss here. Okay, this is about the network reliability using time-dependent probability evaluation. Okay, I hope this is clear to you. Thank you very much.